With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, let's take a question. So here the question is the incorrect statement regarding the 15th group hydrides where we have EH3, E is NPAS, SBBI. These all are our group 15 elements. Okay, so we have to identify the incorrect statement regarding these hydrides. So we will discuss each statement one by one. So the first statement is regarding the thermal stability of the hydrides. If we discuss the thermal stability of the hydrides, okay, so in the thermal stability gradually decreases when we move from NH3 PH3, then we have ASH3 SBH3 and BIH3, right? So when we move down the group, the thermal stability decreases. Why it decreases? Okay, it means that if it decreases, then the order will be like this: NH3, PH3, ASH3, SBH3 and BIH3. Now the question is why it decreases, right? Because the size of central metal atom, okay, the size of central metal atom increases from N to Bi. Size is increasing. Okay, so the tendency to form a stable covalent bond, tendency to form stable covalent bond with the hydrogen decreases. Okay, stable covalent bond with the hydrogen decreases because when the size is increasing but the size of hydrogen is very small, size of hydrogen is very small. Okay, so here what will happen, the bond length increases, bond length increases, okay, strength decreases, okay, strength is decreasing because the bond length is inversely proportional to the strength. Okay, suppose here we have NH, here we have H, here we have H, here we have one lone pair. Okay, so this bond length is increasing when we move down the group, but the bond strength is decreasing. Okay, so that's why thermal stability decreases, that's why thermal stability decreases. Or we can simply say that the size of central metal atom is increasing, so their tendency to form the stable covalent bonds are decreasing down the group. So it means this statement is correct, so it will not be our answer. Next is our bond dissociation enthalpy. Okay, bond dissociation enthalpy is that energy which is required to separate the 1 mole of the bonds. Okay, energy needed to break the one bond, 1 mole of the bond. Okay, so here the bond dissociation enthalpy relates to the bond length. Bond length is inversely proportional to the bond dissociation enthalpy. Okay, so what happens is, if we talk about the bond length, okay, if we talk about the bond length, so here what happens is the bond angle, if we talk about NH3 PH3 ASH3 SBH3. Okay, so the bond angle in ammonia is less than 109 degree 28 minutes, is less than this. Why it is less than? Because if we have seen here that on the ammonia, here we have one lone pair, so it causes the lone pair repulsion. Okay, it causes the repulsion between lone pair and the bond pair of the electrons. Okay, so that's why the bond angle decreases as we move down the group. Bond angle also decreases as we move down the group. Okay, so what happens is the bond length increases, bond length increases, that we have already discussed, that bond length increases. Why it is increasing? Because the size of central metal atom is increasing. Okay, so here if the bond length is increasing, it means that the bond dissociation enthalpy will decrease down the group, it will decrease down the group. So here the order will be NH3, PH3, then we have ASH3, SB, and then it is for the BiH3, right? So bond dissociation enthalpy decreases. So here this is correct, so it will not be our answer. It will not be our answer because here NH will require the maximum energy to break its bond, okay, due to its small size, due to its small size, because due to its small size it forms a stable covalent bond with the hydrogen. Now if we talk about the reducing character, okay, so reducing character means the reducing character. Okay, so reducing character relates to the electronegativity. Okay, so here what happens is as we move down the group, reducing character increases. Okay, why? Because MH bond strength is decreasing. As we have already discussed that as we move down the group, bond strength decreases. Okay, and here we have one another, that is the electronegativity of the central metal atom M decreases as we move down the group. Why it is decreasing? Because of the atomic size. Because as we move down the group, atomic size is increasing. Okay, so that's why as we move down the group, reducing character increases. So here the order is this one: NH3, PH3, ASH3, SBH3, and then we have is BiH3. Okay, so here if we see, here the order is totally opposite, so this will be our answer because this is incorrect. Next is the basicity. Next is the basicity. So if we talk about the basicity, the basic nature, okay, the basic character decreases as we move NH3 to BiH3. It means the order will be this: NH3, PH3, ASH3, SBH3, and the BiH3. Okay, so what happens is here ammonia, this NH3 is the strongest electron donor. Okay, it is the strongest electron pair donor because of its small size. Okay, so as we are moving down the group, the size is increasing, size increases. Okay, so that's why what happens is electron density gets diffused over a large region, and the ability to donate the electron pair decreases. Okay, electron pair donation ability decreases. If it is decreasing, then the what happens is basic nature also decreases. Okay, so basic nature also decreases. So it means that here this is the correct order, so it will not be our answer. So here our answer is option number 3. So that is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.